let's go ahead and write two more functions. We'll do them in separate videos. First, the function I want to write, let's make it main. Let's go ahead and write a function that computes the power function. So basically, we've got a function here where we want to do maybe 2 to the 7th power. So we'll calculate 2 to the 7th power, 2 times 2 times 2 times 2 times 2 times 2 times 2. So how do we do that, right? How do I figure out what the heck is 2 to the 7th, right? Other than having my powers of 2 memorized, right? That is 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7, right? Well, what we can note is that actually 2 times 2, all this over here, right, can be simplified. We can simplify that to, well, 2 to the 7th power is 7 2's multiplied together. Right? And it's the same as saying, hey, we take these two and we turn them into, oh, I don't know, 2 to the 6th, right? Same as 2 to the 6th times 2, or 2 to the 5th times 2 times 2, and so on and so forth, right? So we can say, hey, 2 to the 6th is equal to, let's go ahead and simplify this, right? 2 to the 7th is equal to 2 to the 6th times 2. 2 6's times together times another, or sorry, 6 2's times together times another 2. 2 to the 6th, that's 2 to the 5th plus one more 2 multiplied in there, and so on and so forth until we get to 2 to the 1st power. And you may think that's our base case, and it's a decent one, a decent, candidate for a base case. 2 to the 1st power is just equal to 2. But actually, a better base case is actually 2 to the 0th power is equal to 1. Because anything raised to the 0th power is 1, so we don't even have to return like that method. So, or that value. So let's go ahead and do public static void, or let's go with double for a second, and you'll see why after I'm done coding this. Let's create a pal function, and it will take in a any base we want, double base, and we're not going to figure out how to deal with raising to weird powers like to the to the 2.5 power. We'll leave that for somebody else to do. Instead, I'm just going to put a strict int exponent, make all our exponents strictly integers. So what we're going to do is first we've got to figure out our base case. So if the exponent is equal to 0, right, return 1. Right? Anything raised where the exponent is 0, we return 1. Else, it's fairly straightforward. Return power, or return base times base to the exponent minus 1, right? We take out, what we do is that otherwise we return having taken out the 2 here, right? And we now multiply by 2 to that exponent. Or if we put it in the way that I have over here, right, that's what I've got over here. No worries there. So let's go ahead and run this. Yeah, should print it out, obviously. Pow 2 to the 7th power. Right, it should be 128. Makes sense, 128. Right, so that seems to work just fine. However, we run into an issue when we get negatives, which is that we get a Stack Overflow exception. Why is that? Because we've got a negative exponent, right? We've got a negative exponent here, and we've got a negative number here, so if it's equal to 0, we do this. Otherwise, we keep subtracting 1 to the exponent, which means we keep going further and further and further towards the smallest integer we can get, but we stack overflow before we can wrap around. So that's worthwhile to know. So what should a negative exponent be? Well, if we remember, a negative exponent is the same as saying, hey, 2 to the negative 2 power, 2 to the negative second power is equal to 1 over 2 squared, right? It's just simply 1 over that number when it's a negative exponent. So that actually makes our job not so bad to do this. And this is part of this is the reason I have a double here. Else, if exponent is less than 0, what I'm going to do here is fairly straightforward. I am going to go ahead and subtract. I'm going to go ahead and just make that exponent positive. Right? We know exponent is negative if it's less than 0. So what I'll do is I'll simply return our function base exponent times 1, or exponent times -1. We know exponent is already negative, so multiplying it by -1 will make it positive. And now to make sure it's going to be 1, so it's the correct answer, we'll just do 1.0 over this number. And so now it should be over the 1/28th power. Let's go ahead and do something a bit simpler to check, right? And that makes sense. That's 1 over 4. So excellent.